கொடுத்தாரா நான் கொடுத்தாங்க
47 சார்.
கொஞ்சம் மேம் எல்லாரும் லாகின் பண்ணிக்கீங்க. ஒரு மொபைல்ல அப்படியே எல்லாரும் லாகின் பண்ணி வச்சுக்கோங்க.
Dear participants, thank you so much for joining this plenary session 1. The attendance link for the inaugural ceremony was posted in the chat box. Kindly acknowledge your attendance by clicking that link in the chat box. And you can view the conference Ivcet 2020 in YouTube live also. BHC Tech Talk. The channel name is BHC Tech Talk. You can view the conference Ivcet 2020. Kindly forward to your friends also. Thank you so much.
As we are yet to start the plenary session 1, I request and deem it to invite Dr. Pedro Raj Sir, the Chief Architect and Vice President in the Site Reliability Engineering Division of Reliance Geo Platforms Limited, Bangalore. His previous stints are in IBM Globe Cloud Center of Excellence, Wipro Consulting Services, and Robert Bosch Corporate Research. In total, he has gained more than 19 years of IT industry experience and 8 years of research experience. He finished the CSIR-sponsored PhD degree at Anna University, Chennai, and continued with the UGC-sponsored postdoctoral research in the Department of Computer Science and Automation, Indian Institute of Science, Bangalore. Thereafter, he was granted a couple of international research fellowships to work as a research scientist for 3.5 years in 2 leading Japanese universities. Published more than 30 research papers in peer-reviewed journals such as IEEE, ACM, Springer, InterScience, etc. He has authored and edited 20 books thus far and contributed 35 book chapters thus far for various technology books edited by highly acclaimed and accomplished professors and professionals. It is our honor to welcome you, sir. The time is yours.
Yeah, so thank you for the opportunity to talk something about the emerging technologies to you people today. So I would like to, so I'm Peter. I work for Reliance Geo Platforms Limited. Ours is a kind of product development group, and we are developing a variety of digital transformation products. So in the industry, digital transformation, digital innovation, 1 second. Yeah, I think, yeah, it is not clear because I'm in my native place. Okay, so yeah, so in the industry, we used to talk in very often about digital transformation, digital intelligence, digital innovation, then digital disruption. So these are all some of the keywords, buzzwords in the industry. So today I would like to talk about edge computing, because we are working on that. We are developing a product based on edge computing for our company. So that's why I would like to focus more on edge computing today. So this is, I think you can, I don't know whether you can see my slides or not. 1 second, I will.
So we couldn't see your slides.
Yeah, 1 second, I'm showing my slide.
Okay, sir.
One second. So are you able to see my slide?
No, sir, we couldn't see your slides. Can you share the screen, sir?
1 second. Okay, so there's some problems. It is showing who can share, only host. Are you able to share, see my screen? I think now you can see my slides.
Yes, sir, yes.
Yeah, so the speakers before me talked about various technologies. So that comes under two categories. One is digitization, another one is digitalization. When we talk about digitization, it is all about converting our common, casual, cheap things in our everyday environment into digitized entity. Once upon a time, we talked about computerization, then we talked about softwareization. Today, the word digitization is gaining prominence because all kinds of physical system, mechanical system, electrical systems, and the electronic system in our everyday environments like our home, our hotel, our hospital, our retail store, our warehouses, our manufacturing floor, whatever it is, all kinds of physical system gets converted into digitized entities. So that is primarily through IoT, Internet of Things. Okay, so that is connecting our physical thing into the web or the application or the services that are running on the cloud environment. Okay, when I say web and cloud, they are both are interchangeable nowadays. Everything is becoming cloud environment nowadays. Similarly, when I say web application, it is being called as cloud application, cloud services, or cloud environment. So whatever it is, for example, if your TV at your home or your consumer electronics at your home or it can be your medical instruments, or it can be your robots or drones, or it can be kitchen utilities like that geyser, or some this one dishwasher, or microwave oven, or your refrigerator, whatever it is getting connected with the internet. Okay, that is called IoT, the Internet of Things. Okay, yesterday I was reviewing one journal paper for Internet of IoT access. Okay, so it's an so he could not even properly define what is Internet of Things. So what I'm trying to tell is the Internet of Things is the internet, the future internet. Today the internet is comprising only server machines, a web server, or app server, or database server. So these are all somewhat software, then it is running on hardware. Okay, when I say cloud, cloud is a collection of hardware infrastructure, your server machine, your storage appliances, your networking solutions like your networking solutions like switches, routers, IDC, IPC, all these things. Okay, so these things combine together to form a cloud environment. So when we say web server, it is Apache Tomcat, or maybe Nginx, or Cache proxy. There are so many Envoy. There are so many web server and proxies that are running on cloud environment, that are running on cloud hardware. It can be physical machine, it can be virtual machine, it can be containers these days. Okay, so what I'm trying to tell is when I say IoT, the Internet of Things, it is the futuristic internet. Today, current internet is only comprising server machine, storage appliances, and networking solutions. But in future, our internet will be comprising not only these IT systems that I just told you, but also it will be comprising your connected devices, your cell phone or smartphone, or your microwave oven, whatever it is, your robot, your drones, everything will be connected with the internet. Not only that, it is our table, our cart, our chair, all kinds of physical systems also will be connected with the internet. That's why you might have heard about the word cipher physical system. That means physical systems are getting connected with the cipher applications. It can be your ERP application, it can be knowledge management application, it can be content management application, it can be your HR management application, it can be your attendance management application, whatever application it is, these applications are running on cloud. Your devices at your home will be integrated or hooked or networked with these applications that are running on cloud. The cloud may be in other parts of the world, maybe in Mumbai, maybe in Bangalore, maybe in Chennai, or maybe in Ireland, maybe in Singapore, maybe in Sydney, maybe in Taiwan, whichever country it is, there are cloud centers. And these applications, software applications are running on these cloud environments, or cloud infrastructure, or cloud hardware. And with these applications, our homebound devices, our hospital devices, our hotel devices, our manufacturing floor devices will be connected. So that is about the Internet of Things. So the futuristic Internet of Things will be comprising trillions of entities, trillions of digitized entities. Today we are having maybe 10 lakh server got integrated with the whole internet across the globe. Why I am telling that number is Amazon Cloud has around 4 or 5 lakh servers. Similarly, Google Cloud has around maybe 8 lakh servers. Google Cloud is the largest one because you are getting Gmail, you are getting YouTube, everything from Google Cloud. Similarly, IBM has Cloud Center. IBM has a cloud in Chennai, also in Ambattur area. Similarly, Amazon has a cloud center in Mumbai, and Azure Cloud, it is from Microsoft, that is running a cloud in Hyderabad. Couple of companies are building big massive cloud centers in Bangalore. So maybe next year we will have around 10 cloud centers in India alone. It will have lakhs of servers. Okay, lakhs of servers. So when we add all these servers, it may be 20 lakh server or 25 lakh servers. Okay, that is what the current internet size complexity. But in future, already our devices are integrated with internet. That's why we are watching Zoom over in our devices, our smartphones. Similarly, all kinds of devices will be integrated. It is forecasted that in the year to come, not the year to come, by this year end, without Corona, it would have achieved that number. Billions of devices will be connected with the internet, billions. And by 2022, there will be trillions of devices or sensors or physical system, mechanical system, electrical system will be integrated with internet. That is why if you go to Gartner report, or if you go to Forrester report, or if you go to IDC report, or if you go to KGP website, you can see that by 2022, the internet will be comprising trillions of digitized objects. Now, with the millions of computer servers today, we are exploring the possibility of trillions of devices or IoT devices, IoT sensors, IoT actuators, okay, whatever it is, microcontrollers, chips, stickers, tags, barcode, all these things will be integrated with the internet. Maybe, may not be directly, maybe through indirect method. That because some devices can have the communication module that can directly talk to cloud environment, cloud server, cloud application, cloud databases, cloud services. But some sensors that do not have the capability to broadcast their message, their data to faraway cloud, because we have clouds thousands of kilometers from our places. Okay. So in that case, we will use IoT gateway, IoT bus or IoT service bus, whatever it is. That will be inside our home. Okay. It can be your Raspberry Pi, it can be your Arduino board, or it can be any SPC, single board computers can act as an IoT gateway that collects all the data from multiple sensors. That sensor also inside the home. Then this IoT gateway will transmit the data to faraway cloud. That way, your sensor, your presence sensor, your temperature sensor, your humidity sensor, your gas sensor, whatever sensor you are using inside your home can talk to the application that are running on cloud. Okay. For example, one of the students who was doing a project for his BTech in Shastra University, Tanjavur, he put several sensors inside the classroom, and he could automate the process of the students attending the classes, how their performance, whether they are watching inside the class properly, what their teachers are teaching. All these things can be collected through multiple sensors that are inside that classroom. In that class door, there will be an IoT gateway or RFID reader, whatever it is. That data can be sent to AWS cloud. AWS cloud is running in California, around 20,000 kilometers from Shastra University. Okay, so that is the idea behind this connectivity. So I talked about the Internet of Things. The Internet of Things is all things, all common things. Your cart, your chair, your window, everything will be connected with the internet. There are a lot of use cases why these things have to be connected with the internet. There are a lot of things, but considering the time limit, I'm not entering into the example. Otherwise, it is possible, like, for example, somebody is coming to your home. You have put a security camera in your home door. You are watching TV inside the home. So when somebody is coming to your home, the CCTV camera, the security camera that was fixed outside your home can capture the image of the person who is coming to your home, and can transmit the image, the face image of the person who is standing outside to the corner of the TV, because that gentleman is watching TV inside the home. Now he can see who is standing outside. If the person is a known person, he can orally instruct the door to open it. Now think about that. It looks fancy thing today. How a security camera will talk to TV? Okay, so that is possible. When I was with IBM, we did a similar project for Philips TV. Okay, so through some connectors, some adapters, some middleware, it is possible to connect, integrate different and distributed devices with one another through data format exchange that can be JSON or something like that. So it is possible for integrating multiple devices with one another. That is called D2D, device to device integration. Now, this security camera can also connected with the cloud, so that if you are in the office in the morning time, if somebody is coming to your home, the CCTV camera capture the person and send the message to your phone, because you are sitting at the office, you are not in the home. Then you can orally instruct your cell phone or smartphone to open the door, so the person who has come to your home can enter into the home to take some rest. It is possible. Okay, so that is about the connectivity between devices to devices, then devices to cloud to cell phone. So that sort of connectivity is enabling a variety of use cases, application. hitherto unheard applications can be developed, okay, through such kind of connectivity. Okay, so that's what I would like to tell here. So devices are talking to multiple devices in the vicinity as well as with the remote devices through internet. Similarly, devices are talking to the application that are getting hosted in cloud environment, so that application, for example, if your microwave oven is connected with the cloud, then if you want to make some special biryani, that microwave oven will connect with the recipe that are made available in the cloud environment, because there are so many people who have put the recipe, the things to that components for that, for making some biryani. That microwave oven will get it from that particular website through the connectivity with the cloud, and it will assist the lady to create a biryani as per their liking. Okay, so that is about the connectivity. So now we talked about devices at your home, the cloud application running in a faraway cloud environment. For example, we are all using Arokya Setu nowadays. Okay, recently we came to know that it is not authorized by the central government. Somebody has created it. Some people went against that Arokya Setu to Supreme Court, because Arokya Setu is collecting a lot of personal application. These personal applications can be hijacked or can be hacked by somebody else for their some wrong purposes. Okay, so now what is the purpose of Arokya Setu? You are out in the door road, somebody who is already affected with the COVID-19 is coming towards you, then you will get a message in your cell phone saying that somebody who is infected with corona is coming towards you, please run away from that place. Okay, so now the Arokya Setu is running in a cloud. That cloud is in Kurgan, near Delhi. Okay, now you are in Bangalore. But the data is getting collected from that cell phone. It goes to Kurgan Arokya Setu application, and then there is a message. That message come from Kurgan data center or cloud center to you. You are in Bangalore. So I forgot. Okay, why they went to court? I told you, because of the personal data privacy. Okay. Now the thing is, we are moving towards edge computing. Why edge computing is gaining prominence these days? Already we have been fiddling with cloud computing for the last 13-14 years. When I was with Wipro in 2007, we developed a private cloud in Wipro. Okay, 2007. So now already 2020, it is a very old subject. We will not hear more about cloud the days to come, because one reason is this, because of this cloud edge computing or fog computing, whatever it is, both are one and the same. The cloud computing will not be visible much in the years to come. Slowly and steadily, people will embrace edge computing. Therefore, the cloud computing will lose its phenomenon slowly and steadily in the days to come. It will completely, it will take some, because almost all the enterprise scale application like SAP application or CRM, Salesforce application, around 85% of the software applications today are running on cloud centers across the globe. 85%. Very less number of applications are being stored in our own data center within our campuses or within our institutions. Okay, so most of the applications are already modernized and migrated to cloud. So it will take some time for cloud to disappear from the society, but it will slowly and steadily disappear. Okay, so now come to this point. Now this guy Arokya Setu, why edge? Typically, for example, I am in Bangalore. If I send a data to my cloud is in Navi Mumbai. We have 5 cloud centers across India. So one of the cloud is in Mumbai, other clouds are in Jamnagar, Gujarat, some are in Maharashtra, Nagpur. Okay, so the point is this, there is exactly 1,000 kilometers between Bangalore and Navi Mumbai. Okay, so the data has to travel from Bangalore to Navi Mumbai. Then the application, the data will be processed in Navi Mumbai cloud application, HR application or attendance application or Arokya Setu application, whatever it is. Then the data will travel, the result will travel from Navi Mumbai to Bangalore. Suppose the network is slow, By the time that guy would have crossed, when he comes near to, if he snips, then you may get a chance, you may get that virus. Okay, so what to do? The idea is this: instead of running your Setu application in faraway cloud application, cloud environment, why can't you run the Setu application in your cell phone itself, in your smartphone itself? Okay, so what do you mean by edge? Edge is the device that is very near to you. If you go to retail store, mall, you have to stand in queue. Okay, POS, that is point of sale devices, will get all the details about the product, the size of the product, or quality or quantity of the product, everything, and accordingly it will submit and it will aggregate total amount you have to pay there, and then only you can come out of that mall. But that is not the case anymore. Why? Because with RFID tag, it is possible you just to take the packs from the shelf, put it in your pocket, and you need not stand in the queue, you can go out. Okay. RFID tags will be read by RFID reader. That RFID reader will be in central place, and it will aggregate the total amount. Automatically, it will deduct the amount from your bank account. Okay. Now, point of sale device, it is connected with internet. Now, this device will act as an edge device. So, similarly, if you go to hospital, your CT scan or MRI scan device is an edge device, because you can touch the device, you can feel the device, you can use the device, you can store some information. Because nowadays most of the edge devices are stuffed with a lot of resources like a memory. For example, if you take my cell phone, it has 8 GB memory. Even our laptop also has only 8 GB or 16 GB. So what I'm trying to tell is, all the edge devices are being stuffed with a lot of resources: memory, processing power, okay, 2 cores or 4 cores or 16 cores. Similarly, storage power. Now we have cell phone with 128 GB storage. So similarly, that Raspberry Pi can accommodate with more storage by external addition, external integration. So some of the devices have more power, more storage power, more memory power, more processing power. These devices can act as a edge device. So when we have such kind of devices in our home or in our hospital or in our retail store or in our everyday place, everyday location, these devices can act as a cloud computing device. Today, we put the application in cloud environment. That application runs on a platform. It can be web server, app server, database server, integration server, e-commerce server. So many server software are there. These server software are running on server machine. That is physical machine, bare metal server, or it can be virtual machine, or it can be containers. Okay, these days containers are very popular. So point is this. So application running on platform running on infrastructure. Infrastructure is hardware. Okay. So when I say cloud, cloud is a hardware. Okay, you can touch it, you can feel it, and upon that you can construct a lot of other things and you can run it. So you can show it as a virtual cloud center. You can show it as a containerized cloud center. For example, in Geo, we are building a containerized cloud center, fully containers. Okay. Containers, hundreds of containers can be run on one single physical machine. Okay, there is an advantage. There are so many other advantages compared to virtualization. We are moving towards containerization. Okay, so what I'm trying to tell is, these edge devices will act as a new runtime environment, wherein you can run your web server, you can run your application also. You can run your Setu application. It can run with the MySQL database. Okay, so all the data that are being collected by your cell phone, your smartphone, can land in that database. That database runs in your own cell phone. Okay, and another interesting technology is blockchain technology. Okay, so it also comes under digitalization. So in the beginning I told about digitization. It is about IoT, that is converting your physical thing into digitized thing. That is about digitization. All other technologies in that list that I have shown in my slide is digitalization technology. Your cloud, software defined cloud, it can be your blockchain, it can be your data analytics platform, it can be artificial intelligence, or it can be security, or it can be digital twins, or it can be microservices architecture, or event-driven architecture. There are 13, 14 technologies that comes under digitalization technology. So digitization is all about connectivity. Okay, so IoT means connectivity. It connects everything with the internet. It connects everything with everything else. Okay, so that's why once upon a time when Nokia phone came, they put like this, connecting people. Today, if you go to software companies, you can read the line like connect everything. Everything means your chair, your computer, your table, everything will be getting connected. Okay, so in the till last year, IBM is the only company that was giving work from home facility. Okay, but this year every company has given that because of Corona. Okay, so work from home means typically I can go to my relative house, or I can go to railway station. There I can open my laptop and work. I can tell my boss that I'm working from home. But my boss doesn't know whether he is at happy house, or he is in railway station, or he is in airport, or he is really at home working really. All these things are not known to my boss. But hereafter, with the IoT comes into picture, you cannot cheat your boss anymore. You have to work from home, then only you can clearly, because he can see what you are doing. Okay, so that is possible through such kind of IoT. Everything will be getting connected with the Internet of Things. Now, when IoT comes, there will be petabytes of data. Every day, 2 exabytes of data are getting collected. Every day today, every day, 2 exabytes. Okay, I'm not sure exabytes, maybe 10 power 18. Or maybe 10 power 21. Okay, I'm not sure. So 2 power 10 power 9 is gigabytes, then terabytes to 10 power 12, then petabytes 10 power 15, exabytes maybe 10 power 18. Okay, so that sort of data is getting connected because everything is getting connected with one another. When device A talks to device B, it will generate lot of data. Okay, so now how to collect these data, how to crunch these data, how to clean the data, then crunch the data, analyze the data, mine the data. All these things are done by digitalization technologies. That includes cloud storage. That is for your IoT data storage mechanism. You can store all your petabytes of data. We have very recently, Jio, we have set up a massive data lake that comprises 3,000 servers. Every server has 24 processors. Every processor has 2 cores. Okay, think about that massive data storage mechanism available. Similarly, other companies, our competitors also have such kind of mechanism to store all the data, because we have 1 billion plus devices, geo devices alone in India today. 1 billion plus devices. Okay, so 1 billion plus devices generate 150 petabytes of data. So we need mechanism to store 150 petabytes of data. And on that data, we are doing a variety of analytics, big data analytics, streaming analytics, real-time analytics. Plus, with the artificial intelligence algorithms, we are doing machine learning algorithm, deep learning algorithm, computer vision, natural language processing. These are some of the algorithms that will do predictive analytics, prescriptive analytics. Okay. So, what is digital technology? The technology that converts your ordinary thing into extraordinary thing. That technology that converts your dumb thing into animated thing. Okay. Till now, we don't know how our chair is, but tomorrow, when the chair becomes digitized by attaching some sensor, okay, when we sit upon the chair, it will indicate a communication. It will give a communication to the TV that gentleman is sitting on the chair. So please start TV. Okay, that is the connectivity. So this IoT is primarily a connectivity mechanism. Now, when things are getting connected, variety of data will be generated. That data will be crunched through analytics platform. That analytics platform runs on cloud environment. Okay, so blockchain is primarily for data security. Okay, so these are some of the digitalization technologies. Now, edge computing means I told about that all edge devices that we can touch and see, we can operate it. Okay, your robot is a edge device, but robots are empowered with variety of resources like storage, memory, and processing power. So you can store your application, your platform, your web server, your app server, any software on your robot. Similarly, on that platform, you can run your application, your web application, your mobile application, your embedded application, your IoT application, your blockchain application, your artificial intelligence application, your containerized application, your microservices application, your event-driven applications. So variety of applications. All these applications can be run on these edge devices. For example, if you put 3 or 4 sensor in our body, your pulse meter, your sugar monitor, your heart monitor, all these things are in your body. These sensors are attached in your body. Suppose you are doing morning exercise, suddenly the sugar level goes up. Immediately, this sugar level monitor device will send the data to the cell phone, because that cell phone is in your pocket. That cell phone will act as an IoT gateway. That device, cell phone, will send a message to your wife or your family doctor saying that there is a sudden spike in the sugar level, so please attend to him. So that is it's a kind of connectivity. You can do that. Okay. So this is an edge device. It can be your sensor, or it can be your cell phone, your smartphone, or any device. Now the possibilities. Now I think 11:45. I think I will take another sometime and I will close it. Okay, quickly. Now edge computing. So slowly the computing moves to your edge devices. Till now, computing, data storage, data analytics, artificial intelligence, everything is being done in cloud computers, okay, cloud environments, cloud applications, cloud platform. Now, with the empowerment of our edge device, all kinds of resources, storage, memory, processing, the slowly and steadily smaller kind of your edge devices. For example, you take a CCTV camera. Okay, this edge computing was coined by an Indian. He is working for an American university. I forgot the Carnegie Mellon University, I think. So he published the paper in 2015. Okay, the use case is this. In foreign countries, along the road we have electric poles. In each electric pole they have Wi-Fi gateways. Okay. Now there is a signal. Above the signal, they have kept CCTV cameras. People are crossing the road. Lorries, vehicles are traveling on that road. Now, when the people are crossing the road, the CCTV camera that are there in the signal will see how many people are really crossing the road, at what speed they are crossing the road. All these images will be captured by the CCTV camera that are there in the signal. Okay. Now that CCTV camera will send the images to the nearby Wi-Fi gateway. Nearby Wi-Fi gateway means, as I told you, Wi-Fi gateways are there in the electric pole. That electric poles are along the road. Now in the in the Wi-Fi gateways, we have put the analytics platform. We have put the traffic analytics platform. Now the images are captured by the CCTV camera. Immediately it is sent to they are sent to the Wi-Fi gateway. Wi-Fi gateway immediately crunches the data captured by the CCTV camera. Then it will send a message to the incoming lorry driver, vehicle driver, saying that these many people are crossing the road, please reduce your speed. Okay, so that is possible. That is possible. That is where edge computing came into existence. Why? Because if you send all the images to faraway cloud, maybe the cloud is in Mumbai, you are crossing Maniwala signal in Bangalore. By the time that images reach that Navi Mumbai cloud, the lorry would have crossed the signal by that time. Okay. So we have to do it very quickly, in nanosecond. In a millisecond, we have to do the processing. We cannot wait for the cloud to do all the processing. Because network latency comes into picture. Sending time, processing time, response time will accumulate to become a maybe microsecond or seconds. Okay. If it is taking seconds of time, then by the time lorry would have crossed the signal. So we have to quickly capture. That is called real-time data capture, real-time data storage, real-time data analytics. then real-time decision making, then real-time action. All these things can be accomplished only through edge computing. Why? Because you can run your application on edge devices. Wherever you are, there will be hundreds of devices, hundreds of sensors. These sensors will collect the data, send it to devices. Devices will process it, because sensors cannot process the data. They do not have the storage power. They do not have the processing power. They do not have the memory power. But devices have the memory power. Devices have the storage power. That's why we collect all the sensor data. Camera is a sensor. CCTV camera is a sensor. Nowadays, in big all airports, they have put CCTV camera. With CCTV camera is also having memory power, storage power, what else? Processing power. That means CCTV camera need not send any data to faraway cloud or nearby cloud. Instead, CCTV camera capture the people who are wandering there in the airport, and if there is any anomaly, somebody who has some terrorist activity background, immediately that CCTV camera with the machine learning application will identify that particular person who is wandering there in the airport or in the railway station, and it will send a message to the railway police or airport police to capture that guy. Okay, so that is possible. That is possible through such kind of edge devices. That means data capture is happening there, data processing also happening there, decision making is also happening there. That decision made is communicated to the policemen or other authorities to plunge into countermeasures immediately, so that a major disaster could have been avoided. Okay, so that is the possibility for edge devices. Now I will take another 10 minutes. What are the new trends and transitions that are coming in edge devices? These slides I have prepared for an American conference last week, so I am repeating the same thing here also. But because it has around 50 slides, I could not show all the slides. If anybody wants to see this slide, you can send an email. My email is very simple: peterindia@gmail.com. Okay. So now what I'm trying to tell is some of the innovations, some of the latest trends and transitions that are happening in the edge space. Okay. So I told about that today devices are being stuffed with storage power. That's reason today edge devices act as a computer. Today edge devices act as a communicator. Today edge devices act as a sensor. Today edge devices act as a mission vision enabled devices. Okay. And for example, one of my student who was a BTech students from one Bangalore University, she developed a robot. Inside that robot, it's a handy. She can it will sit on our palm. Okay, such a small robot. Within that robot, she used some Raspberry Pi. Okay, within that Raspberry Pi, she put TensorFlow. TensorFlow is the deep learning machine learning library created by Google. Okay, what is the advantage? When you put that robot in a mall, when you are entering into your mall, it will ask what you want to purchase from this mall. Then if you say, I want to buy some dal or something like that, that robot will take you directly to the shelf wherein the shopper can find all the items that he wants to take to his home. Okay, that is possible through such kind of robots. Okay, that are enabled through artificial intelligence. That is deep learning, machine learning kind of software. Okay, so what I'm trying to tell is today edge devices are becoming powerful, and they can host, they can be deployed with multiple software applications. Okay, now what is the second point? So I told about edge device. Now edge cloud, that means suppose one device cannot handle all the load. In that case, in a home there can be 10 devices. These 10 devices form a cluster, form a cloud. Okay, once upon a time, when I say cloud is a collection of server machines. I told you in the beginning. But today when I say edge cloud, it is a collection of devices. It can be your microwave oven, it can be your refrigerator, it can be your laptop, it can be your Wi-Fi gateway, it can be your Raspberry Pi. Okay, it can be your TV. Any device that has some processing power, that has some storage power, that has some memory power, can act as a edge device. Okay, so that edge device will collaborate with one another in the vicinity, and they will form a small cloud, small cluster. Okay, so that is called edge cloud. Why edge cloud? One single edge device may not be able to handle the full workload, full load of the software, full load of the data. In that case, multiple devices can be automatically clubbed together, combined together to form a cloud. That is called device cloud. Okay. Again, one of my students developed a edge cloud. Okay, he connected several devices within his home. He used containerization there, and he put a microservices. Okay, some monitoring service as a microservice. Then he used Kubernetes. Okay, there is a very latest technology. Okay, so these technologies he used to develop a device cloud within his home. So all the sensors that are inside his home send the data. These data can be gigabits of data. That data will be collected, aggregated, segregated, processed, analyzed, mined by the software that is running inside that edge device to come out with a decision, to come out with some conclusions, to take some inferences, to take some intelligence. Okay, so that is the possibility of running your artificial intelligence application inside your edge devices. So I told about edge devices, then I told about edge cloud. That is the current phenomenon. Okay, then edge AI or intelligent edge. Okay, if you go to Microsoft site, you can find the word intelligent edge. What do you mean by intelligent edge? As I told you, if you run your artificial intelligence software inside your edge device, then that edge device will become an intelligent device. Okay, so for example, as I told you in the healthcare, so their devices will take its own device, and it will articulate other devices to do something intelligently. For example, if you take a agriculture field, okay, so if it is dry, that sensor that is inside the field, okay, it needs some sort of watering. Okay, an Israeli scientist has developed such a IoT enabled or artificial intelligence enabled smart field, paddy field, or some what is that wine, graveyard. Okay, sorry, I forgot the correct word for there. So what is the meaning? The sensor will send the humidity level or dryness level to that decision making device that is also inside that field. Then that decision making device will send the communication to the pump, so that the pump will slowly reopen. It will sprinkle some water into that particular area. All are without any intervention or any instruction or any interpretation from human beings. So that is fully automated, that is fully intelligent. So people are anticipating such kind of AI enabled devices. Okay, that is edge AI. Okay, so this edge AI will be the future. Okay, I think I wrote a your professor wrote a chapter on that for an edge computing book. Okay, so what I'm trying to tell is that is the way. And another interesting phenomenon is this. I told about that maybe 20 lakh servers in all the cloud centers across the globe. It can be Google Cloud, Alibaba Cloud, Oracle Cloud, IBM Cloud, Amazon Cloud, or Azure Cloud. Okay, all cloud combine that. Total number of server machines will be 20 lakhs. But already I told you, we have billions of connected devices, billions of edge devices. So if you sum all the memory power, storage power, and processing power of all the billions of connected devices, it is hundreds of times more powerful than all the server machines, all the computers that are there in the planet Earth. Okay, so that is the future. So in future, that's why I told you in the beginning, slowly and steadily, the cloud comprising server machines will slowly lose its prominence with devices joining, because billions of devices, 1,000,000,000 is 1 billion. Okay, think about that large computing power underutilized by our devices. So slowly and steadily, once upon a time, we coined the word grid computing. The same grid computing concept will pervade in our devices also, so that multiple devices will join together to form a device cloud, and these devices will act as an edge cloud to accomplish real-time analytics, real-time decision making. So for the future, we are expecting digitally transformed enterprises, digitally transformed institutions, colleges, universities, cities, governments, all are digitally transformed cities. For digitally transformed cities, we need real-time computing. Where from this digital real-time computing will come? Only through edge computing, not through cloud computing. Cloud computing will not accomplish real-time analytics, because analytics means real-time analytics means immediately the data has to be crunched, data has to be analyzed, data has to be subjected to a variety of investigations to extract some information, some pattern, some insight, some intelligence, some cognition. These are some of the benefits of having your own private cloud, your own edge cloud. That is why Geo has tied up with Microsoft to set up 1,000 edge cloud centers across India. 1,000, okay, 1,000 cloud centers. In Bangalore alone, there will be hundreds of edge cloud centers. That means if you connect with your customer care, you have to wait for a long time. That is not the case anymore, because all the applications are going to run on edge cloud only. So that the edge cloud is maybe 100 meters from you, or maybe within 1 kilometer. If the edge cloud is in central part of Bangalore, if you are in southern part of Bangalore, maybe 3 or 4 kilometers distance between you, the mobile user, and the application, that the mobile application running on that cloud. That is maybe hardly 3 kilometers, 4 kilometers difference. Okay, then the response will be very fast, very prompt. Okay, whereas if I send a data request, if it is going to Navi Mumbai cloud, that is 1,000 kilometers from Bangalore, then it will take a lot of time. Okay, that will take a lot of time. So today, edge computing will accomplish real-time computing. When we have real-time computing, we will have real-time enterprises. When we have real-time enterprises, we'll have real-time cities. So all your problems in your city, if it is traffic problem, garbage problem, wastage problem, drainage problem, water problem, everything will be solved in real time. When I say real-time, it will happen in nanoseconds, milliseconds, very quickly. Okay. So that is the future we are having. So I would like to stop my talk with one quote. Okay. So I told about IoT. It is for connectivity. It is for making your ordinary system into digitized system. Okay. But what is digitalization? It will convert all your data into information, and information into knowledge. Okay. So what is knowledge? Knowledge will help you take decisions. That decisions can lead to wisdom. So that is the progression from data to information, information to knowledge, knowledge to wisdom. This is getting possible. This is getting accomplished, achieved through digitalization technologies. I listed out several digitalization technologies. So that is the future. So if you take our body, our physical body, all the body components, your leg, your hand, everything will act as an IoT device. Why? Because a lot of data is generated by our body components. Now these body components are collecting the data, and they are sending to our brain. So our brain is the artificial intelligence. Brain takes lot of decision, and that decision is again communicated to all our body components. For example, if you damage your leg while walking, so that pain will go to your brain. Brain will decide what to do. Then brain will tell you, okay, you go to nearby medical shop to get some plaster or something like that. Now, so all the body components are IoT devices. The brain is artificial intelligence algorithm. What is the third thing? Our memory. Memory is the blockchain. What is blockchain? Your data can be today stolen. For example, somebody bought a Audi car and he was going so fast in Germany road. Suddenly the car stopped. Okay, it's a connected car. It is a smart car. It is autonomous car, whatever name it is, or self-driving car. Suddenly in the middle of the road it stopped. Okay, the driver tried every technique, every trick to restart the car. He could not. Then he called the Audi car mechanic. He came. He could not start the car. Then finally he got a call from somebody. in his mobile phone saying that I have hacked your car. If you want to restart your car, please give me $1,000, something like that. So that is the problem with IoT data, IoT device. Today it is easily possible to steal your data, to damage your IoT device. For example, if you put a presence sensor in your home, somebody is able to unauthorizedly connect with your presence sensor. He will send a message to the presence sensor whether anybody is there in the home. The presence sensor will tell there is nobody. Okay, then that guy can steal some of the things from your home. So security is very important. It has to be controlled IoT. It has to be monitored by different monitoring systems. So what I'm trying to tell is IoT, all the body components, brain is your artificial intelligence, your memory is the single source of truth. Your memory resource cannot be modified, altered, or it cannot be hacked by somebody else. Only you can do it. Okay, so blockchain will be very important technology. Yesterday somebody sent a paper to a SCA journal. That paper was rejected. He wrote something about blockchain. I only told him to write something about blockchain, but he didn't do anything on that. So the journal rejected, the reviewer rejected the journal paper, saying that your blockchain implementation is at very shallow level. Then again the concerned candidate called me yesterday. So today I started working on developing a blockchain database actually. So what I'm trying to tell is blockchain will be very prominent. These three technologies, IoT, artificial intelligence, blockchain, will be the popular technologies. I think in the first session, your principal talked about many technologies. There are 10 or 11 important technologies for the future. If you go to Gartner report, you can find that. But the top three will be these three. Okay, IoT, artificial intelligence, blockchain. So one is data collector. That is IoT is a data connector as well as collector. Artificial intelligence, the data cruncher, because it will process all your data to convert your data into intelligence insights. Now your blockchain is the data auditor, data security provider. Okay, so that is the phenomenon of these three. Okay, thank you so much for listening to me. I think I have taken some 50 minutes or 55 minutes. If you want this slide, you can definitely send an email. I will try to send it. Okay, thank you so much.
Thank you so much, sir, for the enriched glimpses of digitization and digital technologies. Really, everyone of the session might learn through this enlightened session talk. Dear participants, attendance link for plenary session 1 is posted in the chat box. Kindly acknowledge your presence. Sir, can you please share your email ID in the chat box that helps them to connect further? Sir?
Yeah, I will do. 1 second. I am chat box. Okay, 1 second. Where is chat? Okay. Yeah, I shared my email.
Thank you so much, sir. Dear participants, if you have any queries, feel free to contact Peter sir through mail. Thank you so much, sir.
Yeah, thank you so much.
Dear participants, we are signing off from plenary session 1 and we are going to enter into plenary session 2. Kindly stay tuned. Thank you, participants, for your patience. We shall now move on to plenary session 2. It provides me immense pleasure and honor to introduce Mr. Ramkumar Rajagopalan, the speaker of the plenary session 2. Mr. Ramkumar Rajagopalan works with Oracle Corporation as regional head, leading a global line of business that provides IT services to banking and financial services vertical. He has more than 25 years of IT experience spanning multiple industry segments, retail communication, public sector, and banking. He has lived in and led large multicultural teams across Asia, Europe, Middle East, Africa, and America. His responsibilities have been both at operational and leadership levels in functions as diverse as product development, program management, sales, client and partner engagement. Sir, the session is yours.
Thank you. Am I audible?
Yes, sir.
Thank you. Thank you. Thanks for that lovely introduction. And it gives me immense pleasure to be amongst the student and the teaching community. And thanks to the institution for honoring me with this opportunity, this wonderful opportunity. Without much ado, I'll just straight away dive into the topic. I'm going to be talking today about the connected world that we today live in. I think, it was beautifully started off by the principal sir and later by our introductory speaker and the plenary speaker about, the connected systems, the cyber physical systems, the Internet of Things, so on and so forth, and how actually we are living in a world where, data is all around us. So I'm going to be talking, I'm not really going to be talking anything totally new from what the earlier speakers spoke about, but I'm probably going to touch upon some important concepts, important topics in terms of the definitions of each one of them, how it all started, where are we headed, and what is it that we need to bear in mind when we are actually, getting on to this high-speed digital journey. Okay, can you please help me enable my screen sharing? I've got a set of presentations and I would want to use that. I'm not able to share my screen yet.
Okay, sir.
Thank you.
Sir, go ahead.
Thank you.
Okay.
Can you see the screen?
Yes, sir. Yes.
Okay, so just a little bit of introduction about myself. So I'm Ramkumar and I'm part of Oracle Corporation. So Oracle has got multiple lines of businesses and I had the professional services line of business, part of the financial services global business unit. So we work with banking and financial service customers across the globe. And I had the JPAC Middle East region, part of Oracle Financial Services Global Business Unit. So just a little bit about, where I come from. And, I'm part of, though I'm not part of Bishop Heber College and I'm not an alumni of Bishop Heber College, I'm really proud to be the part of the alma mater, Church of South India institutions. And I am from, my hometown is Nagapattinam, and I did my schooling, 12 years of schooling, all the way from 1st to 12th standard in Church of South India, Nagapattinam. And you can see that, the picture on the right side, the top right corner, the yellow one, that's how the building used to look, when I studied. And I think, recently it looks like this. So I'm not really very fond of this color. I think, I really have great memories. And thanks to Dr. Sobers for giving me this opportunity. And Dr. Sobers and me go a long way. I just wanted to take a moment to, memories are flooding back. So I wanted to take a moment here to just reflect upon my teacher, Gabriel sir, Dr. Sober's father. He taught me English, and whatever I am today, I think, it all started in the Church of South India institutions, and he was my first English teacher. And I'm really thankful to the institution, thankful to my teachers for where I am today. And without the institution's support, I'm nobody. So, connected world. I think, a lot of examples were spoken about in the previous session. So I'll try to keep it simple. I mean, today all of us are using mobile devices. And in fact, actually today's session is also happening virtually, and it is all possible because we live in a connected world. You have a lot of these devices which can react to your voice calls, voice messages, voice queries. You have the Amazon's Alexa device, and you just, call Alexa and ask it to respond, and it can tell you what is the weather. It can tell you what is the score of a cricket match. It can tell you what is happening with the US elections. It can tell you what is happening with the farmers' protests in Delhi, so on and so forth. And you can actually, further go on to extend the utilization of these connected devices to say that, I want my coffee to be ready in the coffee maker, or I want my car to be started so that the engine is kind of, kept at a temperature for me to get in and start driving. So a lot of possibilities in the connected world. But with that, actually, there comes a lot of responsibility, both at the users level and the organizations which are actually making these things available. So that's what we are going to talk about today. So how it all started, a bit of, history of the Industrial Revolution. So what a lot of, people call today that we live in the fourth Industrial Revolution. It all began in the late 18th century, or the first mechanical revolution. So the introduction of, steam machines and locomotive engines and mining and all that actually kickstarted the Industrial Revolution. So that's the first Industrial Revolution around the end of 18th century. Then moving on to the beginning of the 20th century, or the late 1900s, that's when there were a lot of railroads that got laid. Steam locomotives became operational to carry passengers, to carry goods. Telegraphs and telecommunications were introduced, and even the slaughterhouse, the first conveyor belt of the slaughter machines were introduced in the US in Cincinnati. And all of that actually can be categorized into the second Industrial Revolution. Now, moving on, the world moved into a Great Depression, and around the 1920s, or the late 1920s, early 1930s, when the world came out of the Great Depression, the computer or the digital revolution started. And it started with, the first computer, the Boolean algorithms that were used in the first computer, and use of electronics and information technology for doing some of these works that were all driven by manual labor. So all of that actually started the third Industrial Revolution, and it went on till about 1970s. And I think later part of 1970, early 1980s is when, or even probably a decade later in the 90s, is when the fourth Industrial Revolution began. That's when we got into the cyber physical systems, the Internet of Things, the robotics, automation, all of that came into play. And today we are actually, experiencing almost the mid part of the fourth Industrial Revolution, because people are already talking about the fifth Industrial Revolution, wherein it's going to be more of, human and robotics coming together and working together in a collaborative environment. So that's how it all began. And there are some underlying principles. We'll talk about it. Some of the design elements that contributes to the Industry 4.0. When we talk about Industry 4.0, the fourth Industry Revolution, it of course, goes without saying that the internet has enabled a lot of stuff, and the Industry 4.0 has capitalized, leveraged the internet, the availability of, data, all of that to make a lot of possibilities come to the fore. And when we talk about infrastructure, the internet is the base platform on which a lot of these things are being enabled. The three C's: the connected world, the computing that is available, the communication, the ability to transfer information, the ability to understand each other. So all of that actually forms the core foundation. And then when we move on to the systems layer of it, the systems are the cyber physical systems that Dr. Petraj sir also spoke about, where we have a lot of physical systems which are connected to each other and are also made available on the internet for people to understand how these are functioning, and the control elements are in place so that it can be manipulated from across the globe, from different parts of wherever you are sitting. And in terms of utilization of this infrastructure and the systems that form the basis for Industry 4.0, where do we apply it? So that's where the previous manufacturing revolutions, the previous industrial revolutions, the factory setups that kind of pretty much relied on mechanization. Now it is moving into automation. So where we are talking about smart factories, right from the supply chain, the availability of the base products, the demand that is there for your production, the temperature at which the unit has to be controlled. So all of these things are actually fed in with or without human intervention, or probably with minimal human intervention. So you have a smart factory where a lot of work that is repetitive in nature are taken out of the human hands, and a lot of stuff is done by robotics today. And of course, all of this at the top is boundaried by the internet services that are available. So now we have interconnection that forms the core, and we have information transparency, which means information is available for the different systems to be able to communicate with each other. And you have the technological assistance that is available for these different systems. And because these systems are connected, how do we make sure that the decision processing is decentralized rather than actually having a centralized decision processing? If a decision has to be quickly taken based on different parameters of different systems, an individual system should be able to autonomically take decisions. So all of this forms the core principles or the guidelines under which this Industry 4.0 is built upon. And talking about the various components, there are many digital devices that are actually contributing to this Industry 4.0 revolution. We all know about the mobile devices. We'll speak more about the IoT platforms. We will speak about the location capturing devices, the GPS devices that are there everywhere now, the robotics, the artificial intelligence and the machine learning applications, 3D printing, augmented reality or virtual reality. So all of these digital trends are contributing to the fourth revolution. And added to that is, the cognitive computing, in addition to the Internet of Things platform and the cyber physical systems. How do we make sure that, the machines are given an amount of cognitive capability? What is cognitive thinking? The ability to respond in ambiguous situations. As computer science students, all of us know that we are living in a digital world. Either it's 0 or 1. There cannot be something in between. But humans are not built like that. So now when we are making the machines to mimic a human, we will have to introduce cognitive capability. So how do we actually introduce cognitive capability? So that's where the industry is really progressing, and that's where the next wave, the Industry 5.0 is going to take us to. So now when we speak about Industry 4.0, the present that we are in today, two things that we need to emphasize upon: IoT, the Internet of Things, and the associated data. So that's what I'm going to be spending time on today. In terms of how our lives are kind of intertwined, interconnected with a lot of stuff that we are now so used to. So what is IoT? What is Internet of Things? Internet of Things is nothing but a network of physical objects, which are called, quote unquote, the things, that are having some sensors, the ability to kind of, understand how various attributes, the various parameters are functioning in that particular thing, in that particular physical object. That's the sensor's responsibility. And the associated software, which is nothing but, the ability to understand the data that comes out of the sensors and manipulate that data, massage that data, transform that data, and be able to help you mine and get some meaningful information out of that data. So that's where the software comes into picture, and the other associated technologies in terms of the ability to kind of switch on or switch off a thing, the ability to kind of move something faster, the ability to apply a brake on something. So all of these things put together is Internet of Things, and all of that is connected systems with sensors and software, which is actually connected into the cyber physical world through the internet. So now, how did it all start? It started with very, very small sensor, the RFID tags that today in most of the cars, not most of the cars, in fact in all of the cars, if you have to drive on a highway, you need to have the FASTag, right? So the FASTag is nothing but an RFID tag. So the Internet of Things actually way back in the 80s, and when they started actually expanding on this concept, it was all related to RFID sensors. They were trying to understand, how this RFID technology could be used in day-to-day applications in terms of, tracking, where your machine is moving, some simple application like that. Or if it is a medical equipment, tracking, where that medical equipment, in which hospital, or, where it is being installed, or if it is machinery, where it is being installed, whether it has reached the right site, right destination. So the RFID tags were the earliest sensors that were used in the Internet of Things. We have come to an era where the sensors are probably not so much expensive as it used to be like 20 or 30 years back. So what does it mean? It really means that you can actually put a sensor in anything, because the sensors are not so expensive. They are so-called commodities now. Because of the commoditization of the sensors, you can actually put a sensor in anything and everything. It could be as simple as putting it in a refrigerator that the previous plenary speaker was talking about, or it could be putting it in in your electrical equipments. It could be putting it in even in your jackets. Can you believe the jacket or the shirt that you are wearing today, it can have a sensor. So what can it do? Google actually did this experimental IoT project with Levi's. A lot of us actually wear a Levi's jeans, Levi's jacket. So they put the sensors in the Levi's jacket. So what were they trying to achieve? When we are commuting day to day, we often are disturbed by phone calls, and our urge to actually look at what is happening, who is calling, or what message is coming, right? So Google had this tie-up with Levi's, and they had the sensors in the Levi's jackets, and they tried to use the Levi's jacket itself to be able to communicate with the mobile device by actually swiping off your collar or swiping off your cuff or whatever is convenient for you, to be able to answer a phone, to be able to play music, to be able to skip to the next music in your playlist, so on and so forth. So imagine, where from just a smaller RFID tag has come to today, right? Initially, the founders of Internet of Things technology, they never really thought of that kind of an application, or probably, they thought of it, but then they were more focused on the machine-to-machine ability to utilize Internet of Things, rather than actually, trying to look at the applications in our day-to-day lives. It was meant initially for the manufacturing sector, so to speak. But today it's actually omnipresent. It is there everywhere. It is amongst all of us. And it is getting bigger and bigger and bigger. The amount of sensors that are available today in every household, all of us have a TV, all of us have a refrigerator. The latest TV or the latest refrigerator, if you go and buy, trust me, this will have a sensor. It may not yet be connected to the internet, but it will have the capability to be connected to. So we need to be very careful, because it can capture a lot of data, and that data could be used in multiple different ways. You can have a TV, and the TV can have a camera, and it can actually figure out what is happening in your household, right? Isn't that scary? Yes, it is, but the possibilities are plenty. So essentially, the Internet of Things, what is it? Is it becoming a big giant robo that we cannot really control? I think, the answer lies in the ability to come up with rules, regulations, compliances. I will touch upon that a bit later. But in terms of, ethically utilizing each of these stuff. So I was talking about, the sensor being omnipresent, right? Where are these applications? So let's look at some of the applications. So this is from the Gartner's research last year. And I'm sure, as the year has progressed, it would have even doubled, because the rate at which actually the IoT is evolving is phenomenal. It's not like, incremental. It is really exponential. The major segment, we all speak about is utilities, right? How do you control your power consumption? How do you control, your ability to be able to remotely operate your electrical or electronic gadgets? The ability to be able to switch on or switch off a light, the ability to be able to lock the door, the ability to be able to, control some of these devices. And from a government perspective, we'll talk about smart cities, right? What is a smart city? It's again, a city where everything is connected, right from citizens' requirements to the roads, the communications, the utilities that the government provides, the education, everything is connected. So the smart cities, heavily depend on the IoT, right? And talk about transportation, imagine actually, putting a sensor in the seat of an aeroplane, or a sensor in the seat of a train compartment where you are sitting. And if it can actually feel your blood pressure and take those actions, which are required, probably kind of, adjusting the fan speed, or probably adjusting the AC level, the opportunities, the kind of, you can kind of, let your imagination go crazy. There is so much of possibility that is available, right? So we spoke about, the sensors being there in your dresses, the sensors that are there in the retail, in terms of you walk into a mall, people can capture what you are doing, and, accordingly, or what a smartwatch you are wearing, and it can actually start sending, if your Bluetooth is enabled, and it can start sending you notifications on what offers are going on in a particular retail outlet inside a mall, and can ensure that you are attracted to that mall. Imagine that scenario versus we are so used to actually people standing outside the retail store, for example a garment store, saying inviting people to come to their store, versus somebody sending notifications directly to you. So the options are plenty, and in each and every industry segment that we are talking about, IoT is being leveraged. And like I said earlier, the kind of evolution is not just incremental, it is exponential. The data is as of last year, 2019, August, and in the last 1 year and 3 months, I'm sure, this would have definitely doubled. So when we speak about, IoT, I wanted to also touch upon digital twins. So what is a digital twin? And how does some of these IoT applications are heavily dependent on the digital twin. A digital twin by definition is nothing but a virtual representation of a physical system in a digital world, right? So imagine that, you are running a huge turbine, but you need to understand, how the turbine is functioning, and all of that can be achieved sitting far away remotely if you have a digital twin of the turbine available to you, which means that, the simulated digital representation of that turbine is available to somebody sitting remotely far away. And in that digital twin, you are able to understand the attributes, the functioning of the various parameters of the turbine. And the real-time data of what is happening in that particular equipment is available to the digital twin. So any kind of simulation is possible. And that could be reactive, or it could also be predictive in terms of its application, right? So when you have data available through the digital twin can, use it, apply it to enable some machine learning, to make it more efficient, to make it more better, to make it function in a more optimal way, which is more proactive. Or it could be very reactive. If some component is failing and you know that, that component is reaching the end of its life and it needs a replacement, so you are already actually initiating an order for that replacement to be sent to the turbine, so somebody physically can go there and fix it without any interruption. So imagine that possibility. Now extend that to the virtual representation being yourself. Now physically, we are here. Now if someone can actually take our cognitive thinking capability, what is inside our brain, and create a digital representation of our brain, where does it lead to? We kind of become immortal, right? So those are the kind of, ethical thought processes that kind of come into play when we speak about the possibilities of IoT, the possibilities of cyber physical systems, the possibilities of the connected world that we live in. So some more details of digital twins. So again, a technology description, like I said before, it's a virtual model that aggregate and analyze data about planned versus actual experience of the physical machines, or it could be of a physical, it could be of a process. Now, in terms of its adoption, it's deployed, in plenty of arenas. Talk about a car, we keep actually reading some of these articles that, certain car models are being recalled because actually there is a particular part that has failed. So how do they know this? Inside every car that comes out of the factory today, there is a chip embedded. And that chip actually keeps transmitting the data of how the car is functioning, how the engine is functioning to the manufacturer. So the original equipment manufacturer knows exactly how your car is functioning. And if there is a malfunction, they are able to detect it upfront. So the adoption is there, in the manufacturing industry. And the adoption is there even in, defense situations. You would want to simulate a lot of scenarios in a defense situation, and you don't really want to put your front line in harm's way before actually, you have simulated all the possibilities. So that is another application. So Internet of Things is becoming an Internet of battlefield things, right? So IoT can be expanded into IoBT. So there are multiple possibilities. What are the risks? You can kind of make it more sophisticated. The one that I spoke about in terms of actually extending the cognitive capability itself, you're probably going to kind of make it more complex than trying to use it for the very purpose it is supposed to be utilized for. And it requires some upfront investment, and currently as we speak, the investment in the digital twins is moderate, but it is definitely not on the lower side, and that is the reason why a lot of possibilities exist today in the cyber physical world. Some more details of smart city devices in terms of the connected environment that we live in today, right? So when we talk about smart city, the public security and CCTVs, it's there kind of, that's where, the majority of the investment, it all started in 2017, what you see here in purple. And by 2023, you can expect, an install base of, hundreds of millions of CCTVs that a smart city alone will have. I'm talking about one single smart city here. I'm not talking about the cumulative of all the smart cities across the world. And where is the spending happening? In lighting, in CCTVs, in traffic management, in smart parking, to be able to kind of tell a citizen where parking is available, where parking is not available, and kind of encourage them to kind of use public transportation accordingly. In shared bikes or use the urban transportation. So all of this means that actually you should also be connected to the smart cities devices. So which means actually your data is also available to your government. So just remember that. So where does it take us to? The future is autonomous, which means actually we are moving from centralized decision making to decentralized decision making. 100% of all of the cloud applications in future is going to utilize some form or the other of artificial intelligence. And 75% of that data that is aggregated by these applications will be processed by artificial intelligence. When I say will be processed by artificial intelligence, it will be leveraged, it will be consumed by artificial intelligence machines, which will enable them to kind of apply to the machine learning principles and to kind of take decisions accordingly and to kind of change the tacts. And 85% of all our interactions in the future are going to be automated. Even today, when it sometimes is very frustrating when you want to talk to somebody in your bank or somebody to kind of understand your credit card bills. Most of the times you are actually responded by IVRs, the interactive voice response machines. But more and more these interactions are going to be automated. We have chatbots that are being deployed everywhere, where there is no need for a physical service engineer to be actually chatting with you. It would be a bot, it would be a chatbot. And today it might be a bit frustrating because the chatbot is unable to understand our question, but that's where the machine learning principle comes into play. So what is machine learning? What is ML? Artificial intelligence can evolve only with machine learning. So they are kind of interconnected. So these are just machines, right? So we feed them the intelligence. And when we talk about machine learning, it is the ability of that machine to be able to kind of gather data, process that data, and with the power of that data to become more efficient, to become more better. To put it simply, let's look at an application. Let's take, for example, a simple chatbot that is being deployed to address a service query related to how your mobile phone is functioning. If you have a malfunction in your mobile phone, you log into, let's say you have a Motorola mobile phone, a Lenovo mobile phone, or an Oppo or Vivo. So you log into their site and you are welcomed by a chatbot. And the chatbot is going to ask you some basic questions. The chatbot is going to tell you, okay, so give me this information, give me that information. And to begin with, you are going to start giving it all the information that it asks for, so that you are able to get the response that you want. And what does it do with that information? It could have collected information that is beyond actually what is required for that particular scenario. And at the end of it, it will ask you whether it was helpful, whether it solved your problem. And if you say that it did not solve your problem, it knows actually, there is something wrong in the algorithm that is built in that particular machine, and it would try to change it over a period of time. So it is all using data. So it is pre-programmed in such a way that, it is able to understand the responses and become more efficient. So that is what is defined by machine learning. Now, where is the application of all of this, heading? Voice interfaces, that is where majority of the investment is already happening. We are so used to that. And again, machine learning goes hand in glove with artificial intelligence. Blockchain technology, I would say the blockchain technology is still emerging. even though there is adoption of blockchain technology in financial industries or transportation industries, to be able to kind of, create some smart contracts between people which are not held by one person, but it's kind of, made available in a distributed network, distributed environment. But majority of the investment is actually, the behind the scene work is happening on the blockchain, which may not really be visible to the public yet. But as a consumer, where are we actually seeing that investment? As a consumer, I'm seeing that investment in voice interface. I'm seeing that investment in, augmented reality and virtual reality, where I'm able to kind of visually see the things before I can buy it. Which is what is actually, contributing to headless commerce. In the sense, we are all actually, without going to a shop, we are able to kind of, do a lot of stuff, shopping online. So the manufacturers will embrace AI in the next 3 to 5 years, and already we are at the end of 2020. So this is a bit outdated representation. So this is an data that I gathered from the IDC research. By the end of 2020, 60% of the manufacturers will be using the digital twins to improve the products and processes, which means actually there is, with all this, what does it kind of, really imply? It just goes to say that data is wealth, data is the power, right? So 30% of manufacturers in the next 1 year would have adopted chatbots, so that, there is no manual intervention required in customer service engagements. 70% of manufacturers across the industries will use cloud-based innovation platforms. So a lot of stuff is already moving on to the cloud. It all started with, you focus on what is core to your business. So IT can be left alone for somebody else to manage. So it all started with, in terms of actually moving things to cloud. Now, the possibility of cloud is now, going beyond that. You are just not only disinvesting from which is non-core to your business and focusing only on what is core. As a bank, I might want to just focus only on my banking rather than actually spending on IT, and I would move that IT to cloud. So that's how it started. But now with everybody coming into the cloud, I have the ability to kind of, open up my gateways, my interfaces for others to consume, others to subscribe. So kind of, being from being a physical, bank, now I'm a bank on the cloud, which means I have better ability to be connected, not just only with the consumers, but with the other businesses as well. So a lot of innovation is happening there. And in another 4 to 5 years, the prediction is that 90% of original equipment manufacturers will utilize artificial intelligence to manage the sheer volume of data that these IoT devices are going to aggregate, assimilate. So that's the kind of, data that we are talking about here. So what is next on our digital journey? Now we have data that is available, data that is omnipresent. Next comes visualization, which is nothing but representation of the data. Data is nothing unless it is mined, unless it becomes information, it is nothing. So how do you present that information? So that's where the data visualization comes into play. And from the representation, from the visualization, can you come up with actionable items using that information? And those actionable items, can you automate? So that is where we are headed to. So you have the data, you mine the data, you get the information, you present the data, and you come up with actionable items. And those actionable items, can you repeat it? Can you do it in a repetitive manner? Can you automate it so that the benefits are immense and not just restricted to one of what comes out of it? So from Industry 4.0, the IoT, digital twins, the smart cities, and cyber physical connected systems. Now we move into the data economy. Now, all this prelude is to kind of, make us understand how much of data is being assimilated, how much of data is being aggregated, how much of data is being provided by us as consumers, and how much is kind of, accumulated by the organizations, by the businesses. So data is the new oil. So this is an interesting term that was coined in the 90s by Mr. Clive Humbly. He was the chief architect of one of the largest retail chains in the UK, which is called Tesco. Um, the retail chain actually, wanted to come up with a loyalty program, and he created the club card for the Tesco retail customers. And what was he able to do with that? He said, data is going to be the new oil. I will know what my customers are purchasing. I will know the customer's purchasing pattern. I can generate a large amount of data, and with that, I would be able to come up with, schemes of where I want to provide a discount, where I can actually increase my price point, what I want to stock more, which particular retail chain is performing well, which product has to go into which shelf, so on and so forth. All of that is possible with the amount of data that is available. So you can in a way say that, the Tesco's Club Card program is the earliest of big data implementations. Right now, compare data to oil. During the early industrial revolutions, oil kind of fueled the industrial revolution. Now we are talking about industry 4.0 and moving on to 5.0. Now data is fueling the revolution. Now from the earlier revolutions, oil fueling the economy, now we are moving into a knowledge economy which is fueled by data. And again, like oil in its crude form, it is useless. Data also in its crude form, it is not much of use, because it's just kind of so much of data that is available, and it's all garbage. Now you need to be able to mine it, and the mined refined data is equivalent to the refined oil. But with oil, it was not infinite, right? It was a finite source. It is available only in certain parts, and you can put those rigs, and you can actually extract those oils, but it is finite. So that's why actually people are moving from fossil fuels to green fuels and stuff like that. But data is abundant, data is infinite. It is about what we actually are willing to provide. So with oil, a lot of spillage can happen, a lot of thefts can happen. With data also, all of that is possible. So that is where actually the data protection comes into play. Now wealth was defined as the money that you had that makes you more powerful. And in the knowledge economy, the more the data that you have, the more the information that you can actually mine out of the data, that is proportional to the kind of wealth that you have. So in simpler terms, I just wanted to kind of use an example of how data can be used. We spoke about data availability, to visualization, to actions, to automation. Right now, kind of let's try to kind of look at it this way. The data science is nothing but deriving actionable insights from large data sets. So that's where the business intelligence, the analytics, and all of that stuff that we study in college, in our universities, that comes into play. Now the behavioral science, so that is where I think the next level is in terms of the visualization, the representation. So how do you represent that information so that you are forcing the end user to take some actions? Now, where does computer science come into play here? Be it automation, or be it your ability to kind of create systems and processes and solutions that can actually scale up and can actually deliver the results that was not possible just with just an MIS report. So previously data information, it was all related to kind of providing some MIS reports, the management information system reports. Now we have moved away from that. The data is everywhere. The data is not just related to an ERP environment or a customer relationship management environment. The data is kind of omnipresent, and mine the data, use the data to come up with actionable items. Now let's look at an example. Let's look at an electricity usage as an example, right? So what if actually our electricity board is able to come up with meaningful information data out of how consumers are actually, utilizing electricity, right? So now we see a lot of advertisements on consume lesser power and save the environment and all of that stuff, right? But data is available to the utility provider, that is, let's say in this case, Tamil Nadu Electricity Board or the Bangalore Electricity Supply Company or whoever it is. The data is available. What are the peak times when you have usage, right? And if you understand that, if you have that data, now you present the data in a way, rather than just giving an electricity bill saying, you consumed so many units, you consumed so many meters of units, and this is your bill. Present it in such a way that this is where you are consuming, actually your consumption is on the higher side. So that will be kind of probably, to me, I'm not even aware of it. So that kind of will make me think in terms of, okay, should I reduce my usage pattern? Should I actually switch off the lights? Should I be more careful? Should I not really leave some of these lights on all through 24 hours? So take some actionable items and you deliver that personalized communication millions of times in few hours, so that it kind of registers in the consumer's mind, and you can actually make sure that there is an actionable outcome that you are able to achieve. Now that is the positive side of an example, right? Now imagine this way. Now my credit card biller knows my usage. Now he knows that I'm spending a lot on a particular item. Now he would want me to spend more. He can actually understand my usage pattern, and they can actually present that information to me in a beautiful way, saying that okay, you are a gadget freak, you seem to be spending money on music and music related gadgets. Now here is an offer, 10% discount, and might force me to actually buy something that could be unwanted. And if we were to kind of look back today, a lot of stuff that we are buying today are probably not really something that we cannot live without. I'm sure there are many such gadgets all around us, and I'm sure a lot of stuff that we can definitely live without. So that is a way of ensuring that the businesses benefit out of it, but not really the consumer. So the kind of opportunities that exist are plenty. So where does it take us? You have so much of data that is available. You have connected systems. So artificial intelligence and the future. I strongly recommend this book, Life 3.0, Being Human in the Age of Artificial Intelligence. So there is a lot of fiction that is there in this book. It also kind of talks about the possibilities. A lot of fiction is actually today what is really coming to be more real, right? Whatever we would have seen in some of these old James Bond movies, today it is a reality, and we cannot really deny that. Talking about the machine learning and artificial intelligence, AlphaGo, which is Google's robot, robot which actually played against many humans and actually won championships in a 19 by 19 board games. 3 out of the 5 best of 5, the first 3 games itself it was able to win. And how did it develop? Again, the machine learning principles. It kind of it betters its move based on the opponent's moves. So that is what is machine learning all about, right? So all of this, where has it taken us to? Now, the third picture, I'm sure many of you would have been familiar with, whoever has been following Sophia, the first humanoid or the human robot to ever be given a citizen of a country. Now, Sophia is a robot which was created in Hong Kong by a company based out of Hong Kong. And what is special about this robot is that the cognitive thinking capability was built in. And again, using machine learning principles, it is still evolving. And to give you an examples of how it is evolving, initially it was asked a question. Again, people were kind of trying to test this robot and its intelligence and all of that stuff. People were interviewing, and one of the interviews posed this question: would you destroy humans if you see them as a threat, if you see them as a competition? And the initial response was, yes, I would, because it actually, was going by the word threat. Later, using machine learning and cognitive thinking capability, it understood that it had to connect a lot of possibilities before it can, say an yes or no, right? So later, when it was asked the same question, it again said that it's so creepy that, I answered an yes last time around, but I think, I am today because of humans. And I don't see humans as a competition. I don't see them as a threat. Rather, I would be subservient to the humans. So that was the response, right? So that's how actually the machine learning can actually, be optimally leveraged. Now, all we need to understand here is that, whether it is machines or robots, they're all nothing but the products of data. They're all nothing but the products of what we feed them. They're all nothing but the products of the programs that we actually, create them to perform. And all roads lead to data. So is data a boon or bane? Now, where is the I in artificial intelligence, right? So the intelligence really comes out of the data, right? So there are already a lot of antitrust lawsuits that you might be hearing in the news channels and the newspapers everywhere. For example, Google's Android platform, the Android OS is available free for everybody to consume. Wow, great! So Google is really very generous, right? But are they really? Because at the end of the day, they are a company, and as any business, as any company, your sole purpose is to make profits, right? So you cannot really be running charity. So what do they do? Using the Play Store, which becomes an integral part of any Android device, you are actually forcing people to use a lot of Google's tools. For example, it could be YouTube, it could be the Google Maps. So what does it do? It collects a lot of data. So what does it do with that data? Now, how are the interests of a particular country protected when the data is now available, when it is omnipresent, when it is pervasive, and it is available, across your country's borders. So how do you kind of, contain all of it? It could be as simple as, today we are all, using Amazon platform to buy stuff. Is Amazon an Indian company? No, it is not an Indian company. Now, today, someone sitting in some remote corner in Tamil Nadu, let's say, in Urayur near the Bishop Heber College, and if they are buying some, some cleaning mops, Amazon has got the data. What can it do with that data? So would it mean that actually, they are going to make a Chinese company actually, develop more such mops for a cheaper price and push it into India? So, there are a lot of possibilities, right? So, again, when we talk about smart cities, we saw how many sensors, how many CCTVs, how many devices are going into creating smart cities. So is it all leading to smart governance, or is it going to become smart surveillance? And what can you use the data for? You will know what your citizens are up to. You can actually understand their interests. You can influence their interests. You can actually, do a lot that, we may not really like. So then comes the question, the data privacy and data security. I just wanted to focus on this slide, a lot of bullet points here, but it's very important for us to understand the key difference between privacy and security. Now, when it concerns data, it impacts not just the organizations who collect and manage that data, who assimilate, who aggregate, who use that data, but it also as much impacts, not as much, in fact, actually it impacts the individuals who own the data much more than the organization who collects it. Who are the individuals who own that data? It's us, we the consumers who are actually providing that data, we the citizens who are providing that data. So now, what is the organization's responsibility when it comes to the data security? Security is nothing but, securing the sensitive data, preventing unauthorized access and breaches using firewalls, virtual private networks, tokens, encryptions, a lot of tools and technology that are available today to ensure that the data is secured. Now, what is data privacy? The data privacy is very different from data security. It is about, the consent that an individual gives when it comes to collection of data. The consumption and transmission of that data by the organization which collects that data. Is it in compliance with the regulations laid out by the government, by the statutory bodies? So in a nutshell, it is about privacy is about, leave me alone, right? Because, I have the right to be left alone. And privacy is about using the data responsibly. Now, on the right, you will see some, some pointers around the kind of, laws that are existing today in the world across the globe, the payment card industry, data security standards, the European Union's GDPR regulations, the California state in the US Consumer Privacy Act, the Health Insurance Portability and Accountability Act, and even in India, we have so many such acts, right? So, as an employee of an organization, my responsibility is to ensure that I comply by all of these acts. And if you do not comply, what? The loss is humongous. It can run into a lot of billions, but more importantly, it can damage the reputation of your business. So security is about, ensuring your data is maintained in a secure locker, and privacy is about, your consent to ensure that, you are the owner of that locker. The content inside there is your content, and how do you use that information inside that particular locker? It is your private information, and nothing can be done without your consent. And how those policies got enforced is the security aspect, and what data is important and why, that is the privacy aspect. And a combination of that gives us the protected usable data. So what are those consequences of being non-compliant? Facebook alone, I'm just talking about Facebook as one single entity, one single company alone, has set aside 3 to 5 billion. I'm not saying million, I'm saying billion, B as in Bangalore, 3 to 5 billion US dollars just to manage any potential lawsuits that can come out of the data security and data privacy breaches of the local governments or the international authorities, right? So that's the kind of consequence that we are talking about here. It apparently takes about 280 days on an average to identify a breach. So imagine, you have taken 280 days to identify a breach, and what can be done with that data in 280 days. And it actually gives you a saving of $1 million if you are able to contain that breach within 200 days. And 3.86 million is the global average total cost of a data breach, of one single data breach. A single data breach has costed 3.86 million. And you can imagine the number of breaches that would have existed in 2020. So transparency is paramount, which means the organizations which collect the data, they are being very transparent to the consumer in terms of, how they are collecting that data, what they are going to be doing with that data, how they are securing that data. And bottom line is that privacy is our right to say, leave me alone. Because, people can say, why do you want to hide? Why are you not socially present? What do you got to hide? It could be that, I don't want my photos, my personal videos, my personal preferences, my personal choices, my political inclinations, my religious inclinations. I may want to kind of keep it indoor, inside my house. I don't want to really take it outside my house, outside my door. So leave me alone in the cyber physical connected world. So the data privacy is nothing but our right to say, leave me alone. And again, we spoke about it. The data breach and non-compliance can prove costly. The localized laws can enforce a lot of it. And where does it really take us? there are data privacy law initiatives which are now, becoming a people and social movement. It's not just a government initiative. There are people who are actually fighting for data privacy rights. Um, and I think, that is something that needs to be taken very, very seriously, because there are a lot of users out there, especially in our country, who do not know what can really be done with the data that they are, inadvertently providing. Because all they, when you download an app, you are giving so many consents. You're saying, I give consent to use my camera. I give consent to use my contacts list that is there in the phone. I give consent to use my location. You are saying that, I'm agreeing to everything. We have to understand, every time before we say accept, just before downloading a particular app, that itself is kind of, going to ensure that you are protected. So that's a simple app example that I'm talking about. Now extend it to kind of, the usage in a business environment, the usage in a, an educational institution environment, the usage in a government setup like a smart city. So where do we stand in India? The regulation and enforcement is green, which is like just very limited. It is not fully regulated, which means actually, there is a lot that needs to be done. There is a lot that is still work in progress. But the good thing is that the businesses are already future-proofing their data strategies, because nobody has the kind of money power like Facebook to set aside $3 billion to $5 billion US to fight legal cases, to fight a breach, right? So they are actually making sure that their data strategies are very, very stringent, very, very future-proof. Last but not the least, end of the day, it's the reputation of the business which is at stake, and that's kind of, is really going to drive a lot of behavioral changes. So what can we do? Whether, we as individual or we as part of an organization, we use data responsibly. When I say use data responsibly, it starts from, right from actually giving consent. That is where we come into picture, to the entity which collates that information. The purpose is very clearly articulated. We are very ethical in terms of, making sure that no harm is done to any individual or any business using that data. And the data is used in very, very legitimate, legal, lawful, and fair way. And the data security measures are in place, and only, based on the consent. So that is actually key. So with that, I think, I have come to the end of my presentation. Thank you very much for this time, and I'm not too sure, how much time I took. I was not keeping a tab on it. I hope, you found it meaningful, and you can kind of, derive from this. Thank you.
Thank you, sir, for your thought-provoking words. The session was a knowledge booster. It was a wonderful experience to hear from you. Thank you, sir. Now we have come to the end of the session. Dear presenters, the details about the presentation session has been shared in the conference WhatsApp group. Kindly join with the link provided. I request all the participants to join with us for the valedictory ceremony. Thank you one and all for your wonderful participation. Thank you.
Thank you.
Thank you, sir.